On the left, I have a derivative equation, f dash x equals 3x squared. And what I've done here is I've integrated to recover my original function, f of x. So I've added 1 to the power, x squared has become x cubed. I've divided the coefficient by the new exponent, so 3 has been divided by 3, leaving me 1x cubed. Now I've had to add this term here, which is called my constant of integration, plus c. That's because there could have been a constant in that original function. Let's have a think about this. Let's look at these 3 possible original functions. Each one of these 3 functions, 1, 2, or 3, would have differentiated to give me this f dash x equals 3x squared. In each case, that constant would have been deleted. So it's difficult for me to know what that plus c could have been, or whether plus c was there at all. C could have been 0. Now, it is possible to fully determine a function if we are given a constraint. So if we are given another piece of information, we can determine what that c is, and we can decide once and for all what the original function was, which gave me that derivative equation. So let's have a look at this one. We're gonna find the original equation f of x because we are given a constraint. We are given this additional. Oh, hello, is my pen working? We are given this additional piece of information. The f of x passes through the point 4, 5. Essentially what we're going to do is we're going to integrate, we're going to have plus c, and then we're going to use this piece of information to find c. So let's do that. So firstly I have f of x is going to equal the integral of f dash of x here in terms of dx. Okay, so I have f of x equals the integral of x squared minus 2 over square root x dx. I'm going to do some algebra to really prepare us for integration here. I'm going to say f of x equals, I'm going to split up this fraction, so I'm going to say that's x squared over square root x minus 2 over square root x dx. So f of x equals this integral of, now that's going to be, the new power will be x, the power on this x term will be x to the 2 minus 1/2. So that will be f of x equals the integral of x to the power of 3/2. And in this next instance, that's going to be 2 over x to the 1/2, which is the same as 2x to the minus 1/2 dx. So now we can actually integrate that. So I'm going to say f of x equals. Now what I'm going to do is I'm actually performing this integral step now. So I'm going to add 1 to the power here. So that becomes x to the power of 3/2 plus 1 is going to be 5/2. And now I have my coefficient is 1 divided by that 5/2. So that's going to be 2/5 x to the power of 5/2. Now I'm going to add 1 to the power of this second x term. So x to the power of minus 1/2 plus 1 will be x to the power of 1/2. And my new coefficient will be minus 2 divided by, so minus 2 divided by 1/2, which will be minus 4. Now, this will of course be with our constant of integration plus, oh golly, my pen is not playing ball today, plus c. There we go. Now, this is fine, but I'm going to use my piece of information that the f of x passes through the point 4 minus 5 to find c and fully define f of x. So I know this point, it passes through the point, this function passes through 4 comma minus 5. 4 comma minus 5. Give me 1 second, I'm just going to drop this question down. So I know when x is replaced with 4, so when the argument of the function is 4, my output of this function is minus 5. So I'm going to go through and I'm going to replace every x with a 4. So that's going to be 2/5 times by 4 raised to the power of 5/2 minus 4 multiplies, x has been replaced with 4, so that's 4 to the power of 1/2. I know that's a 2 already, plus c equals that minus 5. So we see we've now got just a nice linear equation for c here. So let's carry on and work this one out. So I've got minus 5 equals 4 to the power of 5/2. So that is 4 to the power of 5 divided by 2, and that was multiplying 4 to the power of 5 over 2, multiplying 2/5 there. So that's multiplied by 2/5. Oh, is that? That seems like it's ordered itself very strangely. Are those two on the same level there? Multiplies. Okay, we're going to take its word for it. That's going to be 12.8 there. So 12.8 minus 4 times 4 to the power of a half is 2. So that's 4 times 2, that's 8, plus c. So then I have minus 5 equals 4.8 plus c. So c equals negative 9.8. So now finally I can fully define my function. I can say that it is f of x equals 2/5 x to the power of 5/2 minus 4x to the 1/2 minus 9.8. So there's no ambiguity about my original function. I know what that function is completely. Why don't you guys try this question here? So given that f dash x equals x plus 2 squared and the original function passes through the point 1, 7, find f of x. So find f of x, substitute for the condition, and then solve for c.